So the big picture for this lesson is trig identities. So here's a Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and that's based on the right triangle with radius 1 in the unit circle. You can manipulate that. If you divide by cosine squared, you get another Pythagorean identity, tangent squared theta plus 1 equals secant squared theta. If you divide by sine squared, you get 1 plus cotangent squared theta equals cosecant squared theta. These are all Pythagorean identities. Now an identity means it's true for all values that you put in. So in this case, all values of theta. So these identities are true for all values of theta. Other identities, reciprocal identities, and these should be pretty familiar. Cosecant theta equals 1 over sine theta, and so on, just the reciprocal functions. Tangent theta is sine divided by cosine. Cotangent is cosine divided by sine. And then again, here are the Pythagorean identities. Cofunction identities, these are buddy functions. Sine of pi over 2 minus theta equals cosine of theta. Cosine pi over 2 minus theta equals sine of theta. Tangent pi over 2 minus theta equals cotangent theta. And it continues on with the reciprocals. These are handy to use sometimes when you're solving equations and simplifying identities. And the odd functions and even functions, those are split up too. Sine, tangent, cotangent, cosecant, those are all odd functions. So the sine of the negative theta is the same thing as the negative of the sine of the positive value. And the tangent of negative theta equals the negative of the tangent of the original positive value. Even functions, cosine of the negative angle value theta equals the cosine of the positive value theta, same with secant. These identities, they're all shown in an identity sheet linked to the beginning of the unit, so you want to make sure you print that out and have it handy when you're working on these. You can also use that sheet when you're doing the unit test, and also you'll be provided a copy of that sheet when you take the final exam. So one of the uses of the identities is you can use them to solve for unknown trig ratios. Here's an example, sine of theta equals negative 3/5, and theta is between pi and 3 pi over 2. Find the other 5 trig values. So what you do is if you use this Pythagorean identity, you can solve for the cosine of theta first, which works out to be negative 4/5 because it's in quadrant 3. Cosine is negative. Then what you can do is you can use these other identities. So if you have sine and cosine already, you can use the quotient identity to solve for tangent. And then you can either use the reciprocal identities or you can use the quotient for cotangent identities you can see here and then solve out the rest of them. So basically when you solve for sine and cosine, you can figure all these out real easily using identities. You can also simplify expressions. Here's tangent of pi over 2 minus theta times secant of theta. So tangent of pi over 2 minus theta, there's an identity that says that's the same as cotangent. So then you're just simplifying cotangent theta times secant of theta, change it to sine and cosines, and then you can just simplify it out and you get 1 over sine theta, which is cosecant theta. So that's what you're going to be doing. You're going to be calculating trig ratios and you're going to be simplifying expressions. That's the big picture.